Dear student, today we will discuss about the statistics. First of all, we see the mean. What is mean?
Statistics is the study of the collection, organization, analysis, summary, and presentation of data. The mean is a measure of central tendency. The mean of a data set can be calculated as the ratio of the sum of data values to the total number of data values. For data values x1, x2, x3, and so on till xn, the mean will be. This symbol is the Greek letter called sigma, which means the sum of all the values, and sigma I equal from 1 to n represents the sum of x1, x2, x3, and so on till xn. Let us find the mean of the data with frequencies for each data item. We have n observations, x1, x2, x3, and so on till xn, with corresponding frequencies, f1, f2, f3, and so on till fn. The sum of the values of all the observations is the sum of the products of the observations and frequencies. And the total number of observations is the sum of the frequencies. Thus, the mean can be calculated as the ratio of the sum of the values of all the observations to the total number of observations. Let us find the mean for an ungrouped data set, the heights of some students in a school. Because the data is so large, we convert it into a set of grouped data in classes, or by defining class intervals and allocating frequencies to them. When data is grouped into classes, we assume that the frequency is clustered around the class mark, which is the mean or average of the two class limits. Thus, calculating the frequencies for each of the class intervals, we can find the mean of the heights of the students by applying the same formula. Thus, the mean of the heights of the students is 159.14 centimeter. This method of calculating the mean is called the direct method. Fill in the blanks with the correct values. When the values of xi and sigma fi are large, calculations in the direct method become complex and tedious. We consider any value of xi as the assumed mean, a. We then calculate the difference between xi and a, which is also called the deviation. Here, the mean of the deviations can be calculated as the ratio of the sum of the product of the deviations with corresponding frequency to the sum of all the frequencies. Substituting the value of di as xi minus a, we get, or as x bar is equal to sigma fi xi divided by fi, we get. Thus, this method is called the assumed mean method. In this method, No matter what value of mean we assume, the final value of x turns out to be the same. This method is easier than the direct method. Tap the button to understand this better with an example. Fill in the blanks with the correct values. Let us learn another method to find the mean, called the step deviation method. Here x1, x2, x3 and so on till xn are n observations with corresponding frequencies f1, f2, f3 and so on till fn. We can now calculate the step deviation ui for each value of I as here A and H are the assumed mean and the class size. We will now multiply ui with corresponding frequencies fi to find sigma fi ui. Then we add all the frequencies to calculate sigma fi. We can find the mean now as substituting the value of ui as ui is equal to xi minus a divided by h, we get. Thus, we get the mean as this holds for any non-zero values of a and h, such that ui is equal to xi minus a divided by h. Note that all the three methods, direct method, assumed mean method, and step deviation method, yield the same value of mean. Tap the button to understand this better with an example. Fill in the blanks with the correct values. 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 Let's summarize what we have learnt in this topic.